Hi students, welcome to the shortcut session to remember divergence formula. We have three different coordinates, one is Cartesian, cylindrical and spherical. Right, each coordinates have different divergence formula. It is very hard for us to remember all the formula, but we can make one shortcut. From that we can understand and memorize those formula. Let us see that. So let us assume A is equal to AX, AX, AY, AY, AZ, AZ. For a Cartesian, this is a Cartesian coordinate. For Cartesian coordinates, everyone knows it is easy to remember also, no need to explain this. But what is the only thing we have to understand here is, you see if the vector component is Ax, there it is differentiating with, it is differentiated with respect to x, right? The vector is changing x component and variation, and we are finding the variation along that component. It is linear force, right? It is contrary to the curl we have seen, that is dou ay by dou z. It is orthogonal. So linear force will give divergence only. So it is divergence. Differentiating, this is changing in the same direction. You see, this is what dou, if it is y direction means this is what dou ay by dou y. See, the vector is changing. It is big vector, it is a small vector. So the magnitude of the vector is changing. Which is the component ay. Ay is a magnitude of a vector along y direction. This is a vector magnitude changing in y direction. Vector direction is also y. You see, this is the direction of vector. This is the component. Right? The change is along the same direction. So this will give divergence. If you keep anything here, it will diverge. It will be pushed. Right? Rather, it will not get rotated. Curl only will rotate. So dou ax by dou x, dou ay by dou y, dou az by dou z. It is a divergence, Cartesian. This we know, but I understand the meaning. That is very important, right? Next thing is, you see, for what you call cylindrical coordinate system, right? Here we have a vector arrow, fi, az, az. So as usual, like Cartesian coordinate system, we write dou arrow by dou phi, dou az by dou z, and dou phi by dou, if dou phi, right, dou phi plus dou a phi by dou phi, and plus dou az by dou z. First we write as usual. Then you see, find the component of, is there any component related to r rho phi z? Here you see we have one extra component rho. There is no phi, not individual phi, individual z, d z, d phi a phi, d z a z, d rho a rho. We have one rho component that you put here, right? Because we have to differentiate with respect to rho. So what you have to do is, instead of d rho a rho, you change this, you include that rho also, do rho a rho, right? Okay, now left hand side, now we got this equation. Now you see that, but here one problem is there. I am adding 1 by rho. Why I am adding 1 by rho? That is very important. You see, what is the unit here? Del is having a unit of 1 by m, right? So numerator unit will be getting cancelled because everything is a, so a unit will be cancelled. But here you see, without rho, what will happen? This is 1 by rho. This is 1 by meter. Rho is a radius, 1 by meter. This is what rho is. This rho is also meter. So what will happen? This meter will be cancelled. If you don't have 1 by rho, what will happen? The unit will not match. That means the equation will be wrong. So what I do, I added 1 by rho here. That's what here. So that means it will introduce that 1 by meter again. Right? Here you see dou a phi, dou phi. This is just a angle. So that's what we have added another 1 by rho here. So you have to add 1 by rho. Now it will introduce that 1 by meter. Here dou az, dz is having a unit of meter, so it will automatically introduce 1 by meter. So now the equation matches. Now you understand, just you write a rho f a z, then include that rho here. So because we have one extra rho, that should be differentiated with respect to rho only. Otherwise you add phi and z, it will become 0. So just include that rho here. Okay. Similarly, we will follow spherical coordinate system. Here you see, in the spherical coordinate system, what do you see? As usual, write this is what vector. So as usual, we write dou ar by dou r plus dou A theta by theta and dou A phi by dou phi. This first we write like we do for Cartesian coordinate system. And what I told, is there any R component, you leave dr AR, d theta A theta, d phi A phi. Remaining thing only you have to take into account. You see any R component, yes, here we have one R, here we have one R. So include that in this, right? Like we did for rho in the cylindrical coordinate system. So what you have to do, you include R squared, right? R squared AR. That R squared I have included. Next you see any theta component is there, extra theta component, yes, sin theta is there. So include that sin theta in theta derivation, differentiation with respect to theta. If it will include here, it will become 0. So no need to include. Here only include. Then phi component, you see any phi component? No. Apart from d phi a phi, there is no other phi. So leave it as it is. Now you see the unit. This is left hand side is 1 by meter. So I want 1 by meter everywhere. Right here, what is the unit? It is 1 by meter. This is meter squared. Yes or no? So 1 dou by dou r is 1 by meter. R squared will introduce a unit of meter squared. So what I need, this meter squared should be cancelled. Then only I will have a unit of meter. So that's what I am introducing, 1 by r squared. Now this will introduce 1 by meter square. This will be cancelled. We have a unit of 1 by meter for first term. That's why we have divided with 1 r squared. Next you see here, it is only theta component, this theta, there is no unit. So what I have to do, I need 1 by meter. So I include 1 by r. This sin theta should be cancelled like we did cancel for this a squared. So include r sin theta. Fine. Okay. Next what you have to do, next we have to include here also phi. So I need 1 by meter. So include r divided by the same parameter. Just remember, we don't have any logic to write this, just remember it, right? So 1 by r sin theta, right? It's not conceptual analysis, it's just a easy way to remember only. So we cannot ask questions about this, okay? Just you put 1 by r, I told what is the reason, it should be a for meter. Sin theta, here we have no option, just you have to remember it, right? Okay, it is sin theta. So this is the way we can remember, right? I hope understand this concept. It is useful for you. Thank you.